All right, there you go. All right, so this piece, time is restricted. Oh, it went away. Time is restricted between pi over 4 and pi over 2. Let's bring you back up. Oh, oh, oh. There you go. So we'll start with pi over 4. We will end at pi over 2. Do we have any other nice value in between? Pi over 3, okay. So pi over 3 is the next one. Let's plug it in. Cosecant of pi over 4. What's that? Which is just simply? Rad 2. You guys agree with that statement? 2 rad 2 over 2, which is then simply just rad 2. Okay. Cotangent of pi over 4. One. Yeah, just like tangent. We love it. So rad 2, comma 1. Now pi over 3. Remember, you can also do sine and just flip it. What's sine of pi over 3? What? Yes, sine of pi over 3, because we'll flip it after. Okay, if you don't remember cosecant. Rad 3 over 2? So we flip it, so 2 rad 3 over 3. Would that be okay? Yes, no, maybe so? Yes or no? Yeah, okay. So 2 rad 3 over 3. Cotangent of pi over 3. Rad 3. What is it? I can't hear you. Rad 3 over 3? Yeah, thank you. No, I can't hear you if you said something. All right, cosecant of pi over 2. What's sine of pi over 2? So close. You mean 1? Yeah. Yeah, that's the other one. The cotangent of pi over 2. Now you can say Zen. All right, so 2 rad 3 over 3, comma, rad 3 over 3, that's that dot, 1, comma, 0. It wants us to graph it out, so it looks like we only have positive x's and y. All right, rad 2 is, let me see what rad 2 is. What's that decimal, so we can approximate it. 1 point something, we know that much. 1.4, beautiful. So rad 2 is 1.4, so I'm going to go 1.4-ish out here. This is your starting dot. You don't have to write starting dot. I'm just writing it so we know because it says show the orientation. And then we have 2 rad 3 over 3, so let's see what that decimal is. 2 rad 3 divided by 3. That is 1.15, so it's a little bit closer. And rad 3 divided by 3 is 0.57. So here we go. I'm going to write this dot right here. 1.15, comma, 0.58. Okay, so that way we know where to approximate. So 1.15, 0.58. So this is sort of a little bit closer right there. And last one, 1, comma, 0. Remember, it asks for us to have orientation, meaning that's showing us the direction. So make sure you have an arrow or two in there. We graphed it by hand, we're good. Now we have to go and write your parametric equation into a rectangular equation. That means you can't have cosine and sine and cotangent, tangent, none of those trick stuff anymore. Okay, so from here, we will go to rectangular. Now, when you see a trig function and you're trying to get to rectangular, you have to use this identity. I will write this one first and see if you can remember. Cosine square of some angle plus sine square of some angle, whatever variable you're using for your angle. In this case, I'm using t, always equals to 1. You guys remember this identity? Yeah. Oh, in our example C, we don't have sine and cosine. We have cosecant and cotangent. So we might want to recall another identity that has that. If I were to divide each and every term by sine square, what's the next identity? Okay, so cosine square over sine square would be what? Cotangent square. Beautiful. Sine divided by sine is 1 equals 1 over sine square is cosecant square. Okay, that is the identity I want to use. In our problem, they gave us x. And what is x equals? What is x equals? Cosecant, yep, of t. They also gave us y. Y is cotangent of t. Guess what? All we got to do is plug it in. Every time we see a cotangent, we will substitute what? Y. We're going to substitute y. So that is now y squared. I'm going to drop the 1 down. I'm going to make equals. Every time I see a cosecant, we are now going to substitute that with x. So that's x squared. Let's put it in standard form so we can see what shape that is. Would you agree I can move the x squared to the left? Yeah, so y squared minus x squared equals to 1. That's as far as I'm going to go in terms of standard form. Anybody remember or recognize what shape this is? Oh, -1. Never mind. I want to move the y over. I lied. Don't do that. I want it to equal to 1. So, sorry, x squared minus y squared. Thank you. Okay. What shape do you think this is? It's an addition, so it's not a circle. I'm sorry, it's a subtraction, so it's not a circle. It's a hyperbola. It's a hyperbola. What's your a squared and b squared? They're both 1. So this is a hyperbola. Yeah, this is just graphing a part or a piece of your hyperbola. So it's not showing everything. Example 2. Find 2 different parametric equations for each of those rectangular equations below. A, would you agree that's a line? This line, what's the domain and what's the range? Are there any restriction for this line? No. So no restriction. So domain is all reals. Okay. Range is also all reals. The reason we want to remember the restrictions, when you do your parametric, they have to fit that restriction. Okay. So they want 2 sets of parametric. Each set must contain an x equals and a y equals. And to go from rectangular to parametric is easy. You can let x be anything it wants to be. Okay? So x can be t. X can be 5t. X can be bazillion t. Doesn't really matter. If you know what x is, what do you think y is? Parametric is x equals in terms of time and y equals in terms of t. So if I know x is t, what is y equals to now? 8t minus 3. They're both in terms of t, and that is parametric. All right, what do you want the second set of answers to be? X should be what? Something different from the first. No, not 0, but that's not going to give you the same domain and range. Huh?
1.
Can't do t again because I already did t.
1.
Nope, because that's going to give me all reals. Remember, your domain and range must be all real. If you do 1, you're not going to have all reals for the y's. 2t, yeah, I have a t. Would that be okay too? 500t? Okay, so 2t, sounds good. So that means the set y equals what? How many t's now? 16t minus 3. Remember, the domain and range must, you have to match up with the original. Okay, so B, x equals y to the power of 5 over 2. When you see a fraction power, would you agree that's the same thing as this statement? The reason I'm writing it like this, because some of you have a better understanding when it's in radical form. What is x cannot be, or what is it that can be? What would x, what's the restriction for x? Would x be negative ever? No, because y is the square root of y. So the restriction for x is x must be positive that's bigger than 0, or equal to, I should say. How about restriction for y? For you to get a value for x, y must also be positive, at least equaling to 0. Okay. So now that we know the restriction, we need 2 sets of parametric. Do you want x first or y first? Which one's easier for us to pick now? Y first, you're right. Pick y, right? And then whatever, because y is independent. X depends on y. So you want to pick the one that's independent. All right, what do you want y to be? 1 t, yeah. You got to say t. If y is t, what is your dependent, which is x? Square root of how many t's? T to the 5th. Would that work? Totally. Okay. Now, would you agree that I had to put an absolute value around this guy? Why would that be? Because, yeah, it has to be positive right there, okay? If I pick, okay, next, what do you want y? What should we pick y? How about t to the power, can I do 2/5? Would that be okay? When I plug it back in, what would you get for x equals? Yeah, look at that. Sorry, this is x equals. But I need to do what? An absolute value there. Okay. I'm going to hold it right there so you can ask me questions. So you can pick, for your independent, you can pick whatever you want to pick as long as it matches your original domain and range. Okay. Example 3. Success if we finish 3a. Okay. The parametric equations for an object, so you have to find it. Find the parametric equations for an object that moves along the ellipse. And the ellipse is x squared over 16 plus y squared with 25 equals to 1, with the motion described in A differently from B. So for A, the motion begins at 4, 0. It goes clockwise, and it requires 2 full seconds for a complete revolution. A complete revolution is how many pi, guys? 2 pi. It's a complete revolution. Okay, so let's sketch out this ellipse. Where's the center? 0, 0, right? It's positioned horizontally or vertically? Horizontal or vertically? Vertically, because 25 is under the y square. So I'm going to go up 5 units. 1, 2, 3, 4, 5. 5 units up. 1, 2, 3, 4, 5. 5 units down. 1, 2, 3, 4. That means your b square is 16. That means b is 4. So here's an ellipse. Okay. Would you agree? It said this particular object moves around this thing. Where does it start? 4, 0. So here's 4, 0. Starting location. What direction is it going? Downward or upward? Clockwise, right? So downward or upward? Yeah, so this is the direction. Okay, that's the direction. Next, it said it took how long to go the entire way? 2 full seconds. So let me ask you this. How many seconds later would I end right here? Half a second later, so I'm going to write half a second. How many seconds later would I end right here? 1. And then that means the top is 1.5 seconds, and then back to where I started will be 2 full seconds. I'm going to wait right here so we can have a better understanding. So far, any questions? I'm going super slow because this is your first one in the moving motion. I will also make a table for you so you have a better understanding where that is, x and y based on time. Okay. When time is 0, x is 4 and y is 0. True or false? At a half second later, where is x and y is y? X is 0 and y is -5. True or false? And 1 second later, x is -4, y is 0. And 1.5 seconds later, x is 0, y is +5. And a full second later, I'm back to where I started, 4, 0. Okay. So parametric, meaning that you need an x equals and a y equals. So x equals and a y equals. Now I'm going to give you a hint. You can have x equals y equal to either one of this. It's going to be some a value times sine b time or b or an a value cosine of some b times t. Either x can be sine, either y can be sine. It doesn't really matter. But those are the two choices for x and y. They can switch. So when time is 0, I would like my x to have a value of 4 based on this. So which one of these will give us an x output when I plug in 0 for time? Sine or cosine? Cosine. Would you agree? Cosine is defined when the angle is 0. Okay, so that's what we're going to pick for x because it's defined. It's not always like that, but for this one, so x equals some b value cosine, some a value, some b value of t. Well, if x already chosen, that means y will get the other one. Okay. Now we need to find your amplitude. A is your amplitude. When time is 0, I would like my amplitude to be 4. So what is in the front? 4. Because isn't the amplitude the height from the center? Is it coming back from graphing curve back in the day? Yeah. So this gets a 4. This is your b, where 2 pi divided by b equals the period. Remember this? So this is where the period is going to come in. So the 4 is your amplitude, okay? Now this b value, if you guys remember, the period back in the days was to find the period for sine and cosine, it was 2 pi divided by b. Remember this? Well, we know a period equals to 2 full seconds, right? I'm gonna hold it right there so you can ask. This is taking everything you've ever studied. A full period takes how many seconds? 2. B is the variable that we need to find to fill it in here. A full revolution, which is full period, is 2 pi always. This will never change. So how do I solve for B? Multiply both sides by B. So 2 pi equals 2b. That means a B is? Pi. Yes, a B is pi. Pi goes right there for both. Okay. Now I just need to find the amplitude for your sine, and we're done. At 0 seconds, would you agree that 0 times pi is 0? Sine is 0, currently is 0. So if I put nothing here, it's going to work, except at a half second later. What is your amplitude at a half second later? -5. So when I plug in a half, sine a half t is what? What's half? Half pi. Pi over 2, sine pi over 2. 1. I would like my a value to be -5. So what must go in the front? -5. Okay. So that gets a -5, and that would be the conclusion of our notes today. All right, take out your homework. Pull out all your homework and your notes. Get ready for your homework quiz.